Quadrilateral that we're going to go ahead and focus on is what we call parallelogram. And a parallelogram is a type of quadrilateral. What's so special about it? Well, its name says that it has parallel sides. So here's the definition, the official definition to a parallelogram. It is a quadrilateral that has two pairs of parallel sides. So if in a word problem or in an example, we're told that we have a parallelogram, we automatically know that by its definition, the sides that are opposite to each other are going to be parallel to each other. So if you guys remember how to annotate the lines, or in this case, two segments that are parallel to each other, it's by using those arrows. So we're going to go ahead and use those arrows. In this case, where BC and AD are parallel to each other, and also AB and CD. So here's AB and here's CD. Those two are parallel to each other. Now notice, because these are two different segments, we're going to go ahead and use two arrows to note that those two are parallel to each other. These two correspond in parallelism to each other, and these two segments correspond to each other in parallelism. So those are the opposite sides. So that's what's so special about its definition. We now know that if we're given a parallelogram, we know that the opposite sides, or the two pairs of sides, are parallel to each other. All right, let me go ahead and move on. Now, another item that we're going to use to create proofs and to do other types of applications is what we call a diagonal. A diagonal is a segment that connects two non-consecutive vertices of a polygon. So here we're looking at our polygon. It's a parallelogram, quadrilateral. Vertices, if you guys remember, they're the corners of our polygon, or our shape. Here in this case, we have the parallelogram, like I said, and it connects two non-consecutive. Non-consecutive means that they're not right next to each other. So here's my first diagonal. It connects my vertex B, my vertex D, and the second diagonal that I have here, vertex A and vertex C. So these diagonals are going to be important in order for us to create those proofs. And also, we're going to go ahead and find out more information about those diagonals in our next lesson. But I wanted to define this so that you guys know. So that point that is created between the intersections of the two diagonals is what we call now point E in this case. So we just name it another point. So if we have it here, parallelogram A, B, C, and D, the next point is E. All right, I'm going to go ahead and construct a parallelogram on the next slide in your Nearpod. You should be able to have the Desmos Geometry Tool website or site open already with the pre-saved sketch that I've constructed for you guys. If you guys want to follow along, and if you're able to put the screen side by side or split the screen, you guys can do that. But we're going to go ahead and construct a parallelogram. And let me go ahead and tell you how by using the program. So let me go ahead and open my tool, Geometry Tool. And this is what you should see so far in your tool. So all you have is a straight line, right? Now, since you have created a straight line, or you already have that line created for you, I'm going to go into my More Tools, and I'm going to select Parallel Line. It's going to ask me to choose a line to set the slope. And I'm going to move that point so that I can create that line that is parallel, because whenever we have lines that are parallel to each other, they have the same slope. And we created that parallel line too, that first line that we created. All right, I'm going to go ahead and create a second line. But in this time, I'm interested on using these 2 points and create a transverse. If you guys remember, a transverse is, it's that line that intersects the two parallel lines. And I'm going to create a second line to this one that I just created, that transverse, that is parallel to that one. So let's go on back to my more tools. Parallel line, I'm interested in, let's see, in this point. And there you go. Beautiful. This line is parallel to this line, and this line is parallel to this line. By definition, we've created a parallelogram. So let me go ahead and create my vertex right here so that I have a vertex, 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 and vertex. All right. Now I'm going to go ahead and create segments between my vertices here, just so I can analyze my my parallelogram, and I'm able to then select the segments, create a label, and color another segment, create a label. It's going to give me its measurement. Let me put that one in green. Segment, create a label. Let's put this one in purple. And this one, let's see, we haven't done red. Let's do red and label it. Now I'm going to do all this here. I'm going to hide what I don't want to view. I don't want to view those lines, but the construction is still there. Now I want you guys to analyze. I've highlighted the segments created by the construction of the two parallel lines, and I've also labeled their measurements. What do you guys notice about my parallelogram?
Two sides have 2.7 and the other two have 7.21.
So two sides have 2.7 and the other sides have 7.21. So in this case, let's see if it's true. So it's that. What if I move my parallelogram? Come on, computer. Is it true? What do you guys observe about it now? What do you notice? What do you see? So no matter how I move my parallelogram, James, James says it's still equal sides. Yes, that is correct. So what's so special about my parallelogram now that you guys notice that I've constructed here? My sides are congruent to each other. And you guys, we're going to go ahead and note them as congruent to each other. These two are congruent to each other. And this is what introduces us to our first theorem. And this is my question here. Let me see. So this is my question. What appears to be true of the parallelogram? It's our first theorem. And again, there's no specific name to this, but we just know that they are theorems about properties of parallelogram. And we're said if a quadrilateral is a parallelogram by definition, then its opposite sides are congruent. So I just constructed here a parallelogram. And the tool allowed us to see that, yes, they are indeed congruent to each other. So in this particular parallelogram, segment BC is congruent to AD, and segment AB is congruent to CD. So whenever we see parallelogram, automatically we know now opposite sides are going to be congruent to each other. So no matter how it's shaped, even if it's around, you can modify it, move it around, whatever one not to your parallelogram. As long as it's still a parallelogram, its opposite sides will be congruent. All right. Give me a thumbs up when you guys have this. Thumbs up. I see one thumbs up. Is everybody else awake? All right. Thank you, guys. Okay. Just remember that you guys have access to the PowerPoint here as well. All right. So let me go on to my next topic. Or actually, before we move on, let me go on to the example. So now we have our first example, example number 1. It's asking us to find the value of y in a parallelogram, and find the length of QT. So here we have parallelogram QRST, and we're given only measurements for the sides or the segments RS, and QT. So we know we're given a parallelogram because it's stated that it's a parallelogram. Therefore, we're going to go ahead and apply that property, that theorem over the property of a parallelogram, where we know that opposite sides are going to be congruent. Therefore, we can go ahead and state that RS is equal to QT. All right, so we know that they represent expressions. Let's go ahead and substitute the values so that we can go ahead and do the first part, which is solve for y. So here we have 2y plus 12 equals 4y minus 4. What do I do first? I have a multi-step equation here.
Separate the variable from the numbers.
Yeah, we can go ahead and yeah, the variable on one side, numbers are constants on the opposite side. So James says add 4 first. We can go any way you guys want. I'm going to go ahead and start with the variables. Okay, you guys know how to do this. I'm going to, let's see, I can subtract 2y or subtract 4y, but in this case, I'm going to go for the smallest variable here. All right, so this goes to 0. I'm left with 12y equals 12 equals 2y minus 4. From here, let's go ahead and do what James said in the chat box. Add 4 on both sides. I have here 16 equals 2y. I'm going to rewrite it so that my variable is on the left side. What do I do next? Divide by 2, thank you. Y equals 8, James said. 8, and that is correct. All right, so now we have our value of y. We ask ourselves, are we done? Are we, there you go. Are we done? No. So we still have to substitute our y value in order for us to find the length of QT. So QT, we know that it measures 4y minus 4. We know that y is equal to 8 in this case. So let's go ahead and substitute that value. And let's see what you guys get for QT. Ramon says 28. Agree, disagree? James says agree. Joshua says agree. Lilith says agree. Destiny says agree. Awesome, and that is correct. So since there's no units, we can go ahead and say, or there's no measurements. We can go ahead and say units. But QT measures 28 units in this case. Awesome. So yes, this is the application portion to the theorem of the properties of parallelogram, the first one that we're going to be introduced to. All right, I'll give you guys 10 more seconds for those of us that need to copy this down. All right, let me go ahead and clear. Okay, so next item that I'm going to address, I'm going to go back to my Desmos geometry tool, and I'm going to not delete, but just remove the lengths, because not only do we always analyze the lengths of our shape, whether it's a triangle, polygon, whatever it is, we also analyze their angle measurements. So with that said, let me go ahead and measure its angle. So I'm going to go ahead and construct an angle at each vertex by selecting one leg, one vertex, and another point on another leg. Sorry about that. Here's a point on a leg, vertex, another point on another leg. And let's see, point, vertex, another point, point, vertex, and another point. All right, so I'm gonna go ahead and move it around. Bring it closer, expand it. I wish I can zoom this in. Can I zoom it in? No, I can't. What do you guys notice? No matter how I move it around. Jane said something. He says opposite angles stay the same measure. Opposite angles, if you remember, they're angles that are right directly across from each other. Let me go ahead and bring them closer and closer. What do you guys notice now? Opposite diagonal angles will be congruent. So yes, they will have the same measure. They will be congruent. So if we have a parallelogram now, in this case, we have opposite angles. Opposite angles, if you remember, they are angles right directly across from each other. And their measurements will always be congruent. So we proved it here through our construction. And even if I continue to move it around, it will always be true. Notice here, I moved it around and I move it again, and they're still the same. And no matter what position I put them, they're going to be the same. So this brings us to our next theorem about properties of parallelograms. So if we have a quadrilateral, quadrilateral is a parallelogram, then its opposite angles are congruent. So here we have measurement of angle A will be congruent to measurement of angle C. Measurement of angle B will be congruent to our measurement of angle D in our parallelogram ABCD. So this is something else that we have here. In this case. Okay, I'll give you guys 30 more seconds. Give me a thumbs up when you're ready. Thank you, James. Thank you, Ramon. Thank you, Brianna. I can barely see you. Okay, you ready for the example? And I'll give you guys a little more time to copy this down as well. All right, let me go ahead and move on. Let's go on to example number 2. Example number 2 says, find the value of x in the parallelogram and the measure of angle TQR. So here we're given the parallelogram QRST. We're given only 2 angle measurements. We're given the angle measurement of angle TQR and RST. Yeah, you can say angle Q and angle S, but I decided to use 3 points to describe the angle. So in this case, because we have a parallelogram, it's stated that we have a parallelogram. Therefore, we can go ahead and apply the theorem and state that the opposite angles are congruent. So we know that this angle is going to be congruent to this angle, and this angle here is going to be congruent to this angle. However, we're only interested in knowing the measurement of this angle. So, and we know that it's going to be congruent to this angle. So let's go ahead and write our little equation. Measurement of angle TQR QRS equals the measurement of RST. All right, so let's go ahead and substitute 8x plus 13 equals 11x minus 23. Go ahead and solve for x. Let's see what you guys get. James is already a step ahead of us. Ooh, we have two solutions. We have x equals 12 already and x equals 18. Another x equals 12. And Justin already has the measurement for angle Q. Let's see. We have two answers for angle Q. We'll go right now. Let's see. Let's solve for this because I feel like we need to address this. Let me subtract 8x, both sides. Subtract 8x here. We get 13 equals 2x minus 23. I need to add 23 on both sides. I get over here, it's 36 equals 2x. Is it 2? No, it's 3x. Oh my goodness gracious, 3x. Divide by 3. Divide by 3. I made the same mistake here. Therefore, x equals 36 divided by 3 is 12. So I made the same mistake here. All right, so from here, we know the measurement of angle TQR. It represents 8x plus 13. Let's go ahead and substitute x with 12, and let's see what you get for measurement of angle TQR. I already have two measurements, 109 and 157. Okay, James corrected himself. And that is correct. Measurement of TQR would equal 109 degrees. Any questions about these two first theorems? So it's the application, knowing now that if we have a parallelogram, opposite angles are going to be congruent, knowing how to identify those opposite angles, and also those opposite sides will also be congruent. Next time we come back in session on Wednesday, we'll see more theorems, but now in regards to our diagonals and more special stuff coming up too. So yeah, this is fun. Any questions? No questions. Okay, let me go ahead and stop recording.